Now that we understand the intricacies that go into solving the mystery of the walrus, we're ready to finally build a list. So the difference between a list and an array is that a list is going to be able to grow arbitrarily large, unlike a Java array, which is of a fixed size. So we're going to build this totally from scratch. And for reasons that won't be clear right now, our list is going to have two variables. The first is going to be an integer called first, and the second will be a pointer or an address of another int list. And our list ultimately is going to be used for storing only integers for simplicity. So let's start off this class. So our class is called IntList, and as promised, we're going to have public int first, and then public int list rest. Okay. Now, if you came from 61A, you roughly know where this is going. Otherwise, maybe a little mysterious. So it turns out that we've actually already implemented a list. We're done. What? How can that be? Well, let's try it out. I'm going to make an int list called L. Okay. So int list L, we can say new int list. And then we could say L.first equals 5, L.rest equals null. And that would be a list that contains the number 5. I could then say, actually, you know what? No, I think L.rest is going to be a new int list. And then L.rest.first is going to be 10. And so forth. Now this is a little awkward, of course, to use, but let's keep going. So we could say L.rest.rest equals new int list. L.rest.rest.first equals 15. And at this point, we, well, can't really see what's going on. So I'm going to take this code, and I'm going to copy it into our good old Java visualizer so we can understand what's going on. So if I visualize the execution of this class, after I create this first list, scroll forward, after these 3 lines of code are done, I have L, an int list, which has a value called first 5 and rest null. So if I run these next 2 lines of code, which I'll skim forward to, so these 2 lines of code are done, L.rest is now a new int list, which has first 10 and rest null. Okay? Well, at this point, if we tried to imagine how would I add a third value to the list, we could say L.rest, and in that case, we'd be talking about this box right here. L.rest.rest equals new int list. So after I say L.rest.rest equals new int list, what do you suppose happens? Okay, so I'll just skim forward just a little bit. We end up getting an int list which has the default values of all zeros. And at that point, we could say, okay, you know what? L.rest.rest.first is 15. In that case, we are telling Java that we'd like to set this box, this memory box here, its bits equal to 15. So what we've done now is built a list. Now, of course, it's a little awkward to use, right? I mean, like, who wants to write code that looks like this? So we can make things slightly better by working a little bit backwards. So first, I'm going to create a constructor where I'm going to say public int list int f int list h, R. Whoa. And then I'm going to say f equals first, rest equals r. Oops, wrong way around. And then what I'm going to do is I'm actually going to build my list the other way around. Okay, so let's try that out. Int list L equals new int list. I'm going to say 15 null. And then I'm going to say L equals new int list 10 L. And I'm going to say L equals new int list 5L. So this is also kind of awkward code, but it's a little more concise. So let's try running this and seeing what happens. Okay, any syntax errors? Nope, good. Okay, so we say int list L equals new int list. That's saying I want a new int list that has 15 at the front, whereas the first value, and nothing as the rest. So after running that, I end up with this. Now I'm going to say, you know what? Actually, you know what I want L to be? I want L to be a list which has 10 at the front and has my old list at the back. So in other words, there should be 10 here, and then this list after 10. So after running this code, sure enough, we get this, right? So L is no longer this original list. It is now the new list we just built, which has 10 at the front, pointing at this one. Now when I say L equals new int list 5L, and if you're not quite following, I urge you to pause the video and try and read ahead and guess what I'm about to do. So what I'm saying is I want L not to be what it currently is. I want it to be the address of a new list, which has 5 at the front, and which points at the old list that I'd created. So in this case, we create a new node. So here's the new list that we're going to point L at. We put the value 5 in, and then you say, you know what? I want rest to be equal to R. What's R? R is just going to be the address that was passed in the constructor, which is the old list. So at that point, rest points at this IntList instance here, right here, the old list. And so once everything's said and done, we end up with the list 5, 10, 15. Okay? So there was nothing new there that we hadn't seen in the mystery of the walrus, though it can be a little bit hard to wrap your brain around. And if you didn't quite get it, watch again and try and guess what I'm about to do.